Welcome to a comprehensive visualization of parabolic dish antennas. Parallel rays from a distant source strike the dish, and thanks to the parabolic geometry, all converge perfectly at the focal point where the feed horn is located. In reverse, the feed emits waves that reflect off the dish as a perfectly collimated parallel beam, demonstrating the principle of reciprocity. But real dishes aren't perfect. Surface errors scatter the rays, degrading focus and reducing gain. High-frequency antennas demand micron-level precision to minimize these effects. Why parabolic? A spherical dish suffers from spherical aberration. Marginal rays focus closer than paraxial rays. Only a parabola brings all rays to a single point. The Cassegrain design uses a hyperbolic secondary to fold the optical path, allowing the feed to sit behind the dish, reducing weight and blockage. The F/D ratio determines dish geometry. Deep dishes are compact. Shallow dishes offer easier feed access. Each design involves trade-offs. Offset designs use an asymmetric dish section, eliminating aperture blockage entirely for maximum efficiency. Off-axis rays form a comet-shaped blur called Coma, limiting field of view and requiring precise tracking. Feed horns and struts block incoming signals, reducing efficiency and increasing side lobes. Another reason offset designs are preferred. Thanks for watching. Like, subscribe, and leave your questions below.